All right, everyone, let's get started. So, welcome to FSMA Friday. My name is Clemence and I work at Safety Chain, and I'll be your webinar host today. So, let's go through a quick few housekeeping items. So, what's FSMA Friday? If you're new to FSMA Friday, these are monthly related news updates, regulatory changes, industry trends, and obviously a Q&A with the Acheson group at the end. This event is brought to you by the Acheson Group and Safety Chain. Before we get started, let's go through a few housekeeping items. Only the panelist microphones are on. Ask your Q&A questions at the end and stop popping them in the chat. Our team will be monitoring and getting those Q&As so that we can also ask to Dr. Tsuyuki at the end. The recording will be shared at the end. And if you're having audio issues, please use the call-in number. Now we're going to go through and present the speaker. So today's speaker is Steve Tsuyuki. Steve has 40 plus years in food manufacturing. He's worked in meat, pet food, and confectionery for multinational companies, holding senior roles in sanitation, food safety, quality, operations, and Six Sigma. Now, he was at Maple Leaf Foods when the 2008 listeriosis outbreak happened and spent the next 17 years building and running their environmental monitoring program as the Senior Director of Corporate Sanitation. Most recently, standardized sanitation practices across 20 plus Maple Leaf facilities. He's been presenting at the Meat Institute's Advanced Listeria Control Workshop since 2009. So he knows how to take complex food safety topics and make them useful for a room full of practitioners. One thing you'll notice about Stephen, he's equally comfortable on the plant floor as he is in the boardroom, and that's a rare combination. Welcome, Stephen. Glad to have you on.
Thank you very much. Okay, so I'm going to move on to...
We're going to go through the agenda first.
Okay, sorry.
That's okay. So first of all, we'll go through some recent regulatory updates, and then we'll go through Steve's presentation, the Seek and Destroy Responding Listeria Positives. As I mentioned earlier, we'll have a Q&A, and then at the end, we'll have a safety chain demo curated to today's topic. So over to you, Stephen.
All right, thank you very much. So as far as the regulatory update is concerned, a couple of topics I wanted to highlight. On May the 6th, FDA announced the launch of a one-day inspectional assessment. The intent here is to strengthen and expand oversight. The pilot, though, is part of a broader initiative to make its inspection resources more targeted and efficient. They're also hosting on June the 15th a virtual public meeting to give people an opportunity to share information on the implementation of food traceability rule and the areas that remain a concern, especially as they relate to lot level tracking and flexibility for compliance. The meeting's free, but you do need to register, and I've included the website at the bottom. Okay, so happy Friday, everybody. The topic is going to be on Seek and Destroy, which is responding to a Listeria positive. What I will tell you is that there is a really good basics training course that the Meat Institute has created. And I would encourage anybody that wants basic training. The course is interactive, self-pacing, and it's free for everybody. So again, you can go on the website. At the end, if you choose to want to get a diploma, you can get a diploma. There is a test at the end, but it provides a really good basic understanding of the terminology and you know the foundation of Listeria control. So the learning objective is a couple of things. So I don't think I can talk about Seek and Destroy without really having spent time talking about you know, the Listeria control program and environmental monitoring. However, that is probably a course in and of itself, and I've spoken to the organizers that that may be another FSMA Friday topic that we may be able to do later in the year. But I do want to spend a few minutes just laying that foundation so that it makes the seek and destroy conversation a little bit more relevant. But a couple of things that I want to highlight in terms of what I'm hoping that I can impart to you is that the Listeria control equation is that foundation for any ready-to-eat operations pathogen control program. The environmental monitoring, though, is not a control measure. It is really just a verification process that allows plants to verify on a regular basis whether or not their plant's Listeria control measures are working as intended. And as far as the seek and destroy process is concerned, when plants do seek and destroy after getting an environmental monitoring positive, when it's done correctly, you're not only addressing the situation with the right corrective actions, but hopefully those corrective actions are both effective and sustainable, and it's like your continuous improvement engine that continues to strengthen your pathogen control program. And in the early phases of development and maturity of your environmental program, it is really a great way to do it. Of course, as you get more mature, then you're hopeful that you're certainly not finding a lot of positives, but those early positives are certainly ones that can drive an outcome that improves your facility when you take the right measures in place. Okay, so the Listeria control equation is that one foundational element. This equation came about in the late 90s when the Meat Institute decreed that food safety is not a competitive issue. They brought together the leading food safety experts across the meat industry, and they agreed on a equation that defines what Listeria control is all about. And this equation has been a bedrock in the meat industry, but I would also say too that people like Dr. John Butts and Joe Stout have also taken the basis of this equation and helped set up with the Dairy Association and the produce industry comparable equations. So this equation should be out there. And I think we're coming now to the first polling question, and I'll pass that over to our hosts.
Thank you, Steve. All right, we are going to start with the polls. So please go ahead and participate and engage as much as you want. So number one, are you familiar with the Listeria control equation? Yes, I know all 5 control factors, somewhat, heard of it, but don't know all the details. No, it's new to me. And then finally, I know the concept, but by a different name. Let's see what we have. We'll give you a few more seconds to answer. Okay, well, thank you. We're going to take a look at the results now. Let's close the poll team. Okay, so Steve, as you can see, there's about 29% that the top 2 answers are no, and then somewhat.
Mm. And as I have been meeting clients in FDA facilities, I would tell you that's a common answer, that they're either not aware of it or somewhat aware of it. And that I think is a challenge, because, as I said to you, there has to be a basis of control. And so when you look at the elements of the Listeria control equation, every element, every factor has a plant controllable purpose. So, we talk about controlled traffic patterns. That talks about segregation. So, again, every plant needs to define the scope of, what is really at risk in terms of exposed, ready to eat product that is either being processed or to be packaged, so that so in the meat industry, that would be after the thermal lethality step. Now, I understand that if you're in produce, as an example, that may be after your intervention washing step, and again, all these things have different nuances, and they're going to have to be applied, given your processes in your facility. But this is about identifying what control measures you have in place for traffic, for GMPs, to make sure that your infrastructure is sound, to make sure that you have effective sanitation practices, and to make sure that the sanitary design of your equipment and building are sound. And what I would tell you on this one is we often focus on sanitary design. So, is the equipment, is it preventing harborage? But I would say equally to this, something that we are only starting to look at more and more is there is an element of managing the wear and tear of equipment as it goes through cycles of operating and cleaning and operating and cleaning. And that is where the wear and tear of equipment has to be maintained, and that falls under the maintenance and the preventative maintenance. So that aspect is also emerging as a very important factor in how we manage our program. There is a real overlap between the Listeria control equation and what we would consider to be elements of the pre-rep program. So these aren't additional things that we have to think about. They are aligned to other processes that you have in your food safety system. So they shouldn't be anything that's new. So, a long time ago, Bruce Tompkin talked about the fact that, what we want to create in our environment is a torturous path for, if Listeria is in the building, and I think most ready-to-eat plants will say that, to say that they don't have Listeria in their factory, I think is a challenging statement to make. But what we can do is we can prevent Listeria from where it's residing to getting to either food contact or eventually onto product. And so our opportunity, our obligation every day is to make sure that our control measures, based on the factors that we have, that they're working as intended. And that is what the environmental monitoring program does. The swabbing helps to verify that these control measures are working, so that when you do get a positive, it means that one or more of these factors has failed in some way. And I think that's the element that I want to bring into play here, so that we can have this conversation then about seek and destroy. So with that, I think, one last slide. Too often we think that seek and destroy, and especially the managing the environmental monitoring program, is a FSQA responsibility. Sometimes it's also FSQA and sanitation. I would tell you that in mature facilities and facilities that have good programs, it takes the participation of the entire village. So to illustrate that, when you look at the factors of control, the top three: controlled traffic, GMPs, infrastructure, those are all operation responsibility. The sanitary design equipment, the maintenance, making sure that that we if we find things that are deficient, like cracks in the floor, or issues with equipment that will increase the risk of harborage, then those are things that maintenance should be taken care of. And then, yes, obviously cleaning the equipment, both the routine cleaning as well as the non-daily periodic tasks, that's sanitation responsibility. But everybody needs to participate to make sure this program is working effectively. So I think with that, we are going to move then to talking about seek and destroy. And I believe we have another poll question.
That's correct. So we're going to have a kind of a true or false question. So true or false? In Seek and Destroy, Seek is simply the monitoring program that triggers the destroy cleanup when Listeria is found. Is it true? False? Partially true? Or false? Destroy means sustainable corrective actions, not just spot cleaning. Let's see what we have. A few more seconds. Some good engagement there, Steve. Okay, let's close the poll now. Okay, so as the poll is closed, we see that 57% chose false. Seek is a full instigation to find the contamination source and transfer vectors. Then we also have false. Destroy means sustainable corrective actions, not just spot cleaning. And we have a few people who answered partially true. Monitoring starts it, but Seek goes much further.
Well, that's encouraging, I must say, and that's very good, because I would tell you that the challenge that we face right now is literature and how people talk about seek and destroy. It is really split between two camps, and everybody on this call, it would appear, to have at least some bias towards investigation. But I can also tell you that remediation is a very strong bias. And what I would also say to you is when I reviewed the pre-presentation questions, it was very interesting that half of the questions talk about vector sampling, which I'm assuming is a little bit more biased on the investigation. But there were also about half the questions were around cleaning, innovative chemicals, innovative techniques around, remediating Listeria. So there is also this bias towards remediation. So it's good from a polling point of view that everybody is at least showing a bias for investigation. But I would say that the reality is that the intention of remediation is so strong that this is really going to challenge how your organization and your plant works. And I honestly believe that if you do bias towards investigation, we talk about this continuous improvement engine. It's only going to get stronger, or you're going to have much more horsepower if you are focused on investigation. So let's move to the next slide. So I actually had a situation where a company was treating, had a drain positive, and they were showing the data that shows that they were basically remediating the drain, positive come back, remediating in the drain. And the comment I gave back to the plant manager was that kind of sounds like whack-a-mole. And he basically said, well, what do you mean? And I said, well, it's kind of like, you see something pop up and you hit it with chemicals, and then it pops up again, you hit it again, and he got really upset with me, and but I said, well, do you have any other data? And all of a sudden he presents other data, and I said, well, yes, it sounds like you are doing some other investigation, but are you really thinking about remediating the drain or trying to figure out what's coming to the drain? And I'll be, I don't want to, we'll have a further conversation about that later in the presentation, but that's the choice that companies have to make. But if you are treating a environmental positive like you found it, and that becomes your seek, then all your efforts then are now in destroy mode, which means you are focused on remediation, which means you're intensifying your cleaning, you're really focused on that positive area. You are now also then focused on getting those three negatives as a result, so that you're trying to minimize the disruption that a additional positive may have. And even if you don't get to a root cause, the plant still moves on, and you resume regular production. And unfortunately, in those cases, what may happen then is several weeks will come by, and you'll get a positive in a very similar, if not the same site, because quite frankly, you haven't actually figured out where the root cause was. If you're in this investigative mindset, then you treat seek like it's truly meant to be, which is about finding it, which means you don't know where it's coming from and how it got to that site, but it's all about now investigate to try to figure it out. And I often talk about it's like a CSI investigation. You're trying to determine, okay, so the site and the equipment and the line, the affected line, it's like my crime scene. How do I now figure out what happened? How did it get there? And in order to do that, that's not just one person or food safety and sanitation working together. It should be a team sport. There should be everybody that works together, and then it's about what swabbing do we have to do once we kind of think about what it could be. But you're not swabbing like you would do under routine conditions. You're now swabbing in a much more purposeful, targeted way, but it's very different from routine swabbing, and that's because you're actually trying to solve a problem. So before you even start swabbing, the reality of this situation is you swab a few days earlier, you get a positive. Well, you know what? It's not just a crime scene. It's actually, the crime is actually still happening. So, the best practice would be that when you get a positive, when you receive that positive from the lab, the first thing you should do is actually go out on the floor. Take a bunch of people and go together and observe the line that's impacted. See for yourself how the flow of the product and people and equipment, see if things are moving the way they normally would. Is there something going on that has created some non-routine activities? What are the GMPs looking like? Are people following good GMPs? Hopefully, you're not, let's say, you're not someone that someone goes, well, who's that person that you're kind of, people know who you are. So while they may look at you and wonder why you're there, they're going to necessarily just kind of follow their routines. But the things that you want to look for is, are they following good GMPs? Are the floors in good condition? If you're running a process that is relatively dry, is the floor dry? Is it semi-wet? If it's wet, where's that water coming from? Asking questions about, recent sanitation performance and what some of the challenges are. Actually, if you're doing a sanitation cycle, see how the transition from production to sanitation is. Talk to the sanitors and ask them what challenges recently are they finding. What burden of cleaning are they having to deal with that you may not be aware of. Look at some of the accumulation of product on the equipment, maybe some wear and tear that again might be factors. Talk to the frontline people. The frontline people know more about what's going on than probably anybody. And so again, hopefully you've built relationships with people that when you talk to them, they're going to be open and honest about what's going on, and you might find some insights that you're not aware of in terms of activities and things that are real challenges right now that might actually be factors that are causing these problems to occur. And then finally, what I would say, and this is where I think FSQA earns their keep, pulling the data together so that when you meet as a team, it's not just a bunch of reports or spreadsheets, but there's some context to the information. Being able to, quite frankly, plot the data on a CAD drawing so that people can sort of visualize to see it. Because, again, if you want the HR person to participate in your seek and destroy, it helps them immeasurably if you can kind of put it in a very simple way what's happening, and then you're going to get them to participate in a meaningful way. So as a team, what you want to do is you want to start brainstorming and thinking about what could have failed and coming up with ideas or possible causes. Probably no more than 3 to 4 possible causes, and don't ever get influenced by the loudest voice in the room. But for each one, so here, I put an example where, the floor spurts water when I stand on it, or, the gloves of the people's hands where there were, that they may be touching product, but actually they may be also touching some others, or they may be actually working and touching product from another line. These are sort of things that become meaningful in any investigation. And then what you want to do is you want to develop a sampling plan that is going to help you prove or disprove with data some of those things. So, I often use the terminology spreaders and shedders. So you can kind of split the factors as spreading factors. So, controlled traffic, when you have movement of people or equipment, then when you move things on the floor, especially if your floor is wet or semi-wet, you're spreading potentially you're spreading contamination around. You're certainly spreading water around, which can be a great transfer vector. I talked about gloved hands and how hands and people can be transfer vectors. Just that innocuous movement of people, maybe touching product, but then having to grab a bin or move a pallet or touch a control button, and how the movement of hands can actually either pick up contamination or then transfer it to another location. Shedding, we talk about sanitary design, the ability of equipment to potentially harbor. We talk about, a crack in the floor. So when a floor is wet and you step on it, and because of delamination, it spurts water. It's very difficult even though that water is cleaned by sanitation and you've cleaned it and you sanitized it, if you don't displace the water that is in between the layers, you're actually not going to get chemical to where the bacteria actually is growing, and that becomes a real challenge. So there are different ways of sampling. So I'll talk about some of these in more specific, but the one thing I would tell you that in terms of well, actually, you know what? So I think what I'll do here is, because I don't have slides to talk about some of the so the one element of shedding, I will spend a little bit of time here talking about that. So when we get a positive on a piece of equipment that has multiple layers, some of the challenges around that is how you then go about investigating that piece of equipment. And oftentimes, you know, we get just so aggressive in terms of, you know, just cleaning, you know, cleaning that equipment. And but what we should be doing is with that investigative mindset. Yes, clean it like you normally would clean it. But then what you can do is, after it's been cleaned under normal routine conditions, take one layer of guarding, or take one layer of equipment surfaces off the machine and see if you can see any debris. Swab it, take another layer off, and keep taking layers off until, you know, basically, you know, it's as far as you can go. And it's that peeling of the onion effect, that if you find bacteria underneath the layers that you typically don't take off under normal routine cleaning, it means that your routine cleaning is not going to be effective, that you've got harborage inside your equipment. And in order to get rid of that harborage, it means that you're going to have to either have a level disassembly that allows you access to where the soil and water and bacteria have accumulated, or you may then need to do an intervention like heat intervention, which basically heats the equipment up to a level that actually will kill the bacteria, even though you're not actually seeing it, but you're killing it through conduction. You know, one thing about Listeria, it is very heat labile, which means it's not that hard to kill Listeria using heat. So when you're looking for bacteria and the movement, this picture on the left, it was really interesting. In an investigation, in a seek and destroy investigation, a plant provided a schematic, and what they did was they traced the movement of all the people and equipment, and it was used as trying to figure out, you know, the movement of things. And I thought to myself, you know, when you do a time series sampling event, you're actually doing the same thing, but you're using swabbing as your means to detect for the movement of bacteria. This is a very challenging way of swabbing. It's a very intense way. But if you can reduce the scope of your area, but then basically swab at multiple points in time, what you really are trying to do is you're trying to catch Listeria in motion, so that you understand where it first appears and how it spreads to the different processing areas. It is a very effective way of at least understanding movement. So an example of this, and you know, I'm not, you know, hopefully you can see this, but you know, this was a time series event in a what we call a slicing hall, and our initial hypothesis was that it was in the hall already, and it was spreading. But what we found out by, you know, and I didn't take every hour that we did, but I took a snapshot of the first hour and towards the end. But what we actually found out when we did time series sampling is it always showed up in the back end of the process. So this is where the meat logs were coming into the slicing hall. So this changed our thinking around where the contaminant was coming from. It changed from thinking that we had harborage and equipment to actually it was coming in from the logs themselves. And when we, it was actually on the casing of the log. And when we peeled it, the first point that we saw was the hands of the people that their job was to peel the casing from the log. So this is where time series sampling can be really effective, because it takes a situation and it gives you way better information than using traditional methods of sampling. The other type of sampling that you can do is rinsing sampling, and this is looking for spreading bacteria. So this is about if you have harborage in equipment, it's kind of like how do you determine whether or not you have harborage. So Dr. John Butts first provided this as a tool to the Mead Institute several years ago, and it's a great practice, because what it does is it adds a dimension of investigation that we just aren't able to do under normal circumstances. So the concept here is you use the process of sanitation as your friend, and you also use the fact that gravity pulls water down. So when sanitation occurs, and this is immediately after the final rinse step, where water is either in the equipment, on the equipment, you're going to get water falling down to the floor. The real nuance of this is we're not trying to swab the rinse water, so that initial rinsing of the water is not what you're trying to capture, because if you're going to do that, then chances are if there's bacteria there, you're going to find a very diluted sample, and you're probably not going to find anything. The trick is to wait long enough so that, especially on the internal surfaces of internal components of a piece of equipment, you're going to get dripping from, whether it's a bearing or inside an enclosure, and it's kind of that weeping water. So if you wait long enough, you can swab the bottom surfaces, the undersides, the juncture between the equipment leg and the floor, to really understand, can I find microbes at a level that would open up an opportunity. So here's an example where we were actually looking for lactics in one of our plants, and you can tell here that this is a jump conveyor just after the meat slicer. The floor is relatively dry, so that means we didn't collect the immediate rinse water. We let the water kind of drip down to the floor, but we swabbed the bottom leg of a jump conveyor, and we got a hit. And once we found that result, we went back and we opened that enclosure. We found meat debris caught between the cover and the gasket. And you know what? That equipment, the gasket, did its job, but what wasn't good was the fact that the design of that cover allowed meat debris and water to be entrapped there, and that's what we were finding. But we would never have found it if we had to physically remove. We didn't know that was there. The only way we found it was by doing a rinse-aid or post-rinse sampling, and this is a technique that adds a level of dimensionality that you don't have. So, we can swab a floor, we can swab on equipment, but what you don't get is that vertical dimension. And a rinse-aid or post-rinse sample gives you that vertical dimension, also gives you the dimension of internal to external. So, beyond the seeking part of seek and destroy, we can't forget about remediation. And there are a couple things to talk about remediation. The first thing is that, you know what, nobody wants a second positive. So there are going to be short-term corrective actions that are going to be in play, but they can't, you have to really be careful that whatever short-term measures you're taking can't interfere with the investigation component of your, the seek part of seek and destroy. But, having been here so many times, I know that, you have to have some level of remediation in addition to investigation, but those two tasks need to work together. I would also say too that you're going to need to make sure that and I get it, especially in the FDA world, where there is, I would say, a fear of testing food contact. You're going to have to be careful how you're sampling, and so I would encourage you as well to use other tools other than testing for the pathogen, and oftentimes to support investigative swabbing, we will also test for TPC and even ATP, and while they're not replacing testing for the pathogen, if you've got some understanding and some relationship between TPC and ATP to your pathogen results, you can get some strong indicators when TPC or ATP results are higher than what you would expect, and they may help you at least give you some direction in terms of what you need to look at and what is something that would require further investigation. The other thing is that when you're in destroy, you want to think about making sure that your corrective actions are going to be effective and sustainable for long term. And that's where getting to a root cause is so important, because if you get to a root cause and they're effective and sustainable, then you've made your program better, but in the end, it's a sustainable benefit, and that's how you start to really turn that continuous improvement wheel. So you can have two types of destroy elements. You can either design out the problem, or you can put in a procedure. And for a Friday, I thought we could talk about this notion about so here's a situation in a mall where they don't want people to skateboard on the boulevard, and so they could put a sign. So if you look in the back, there's a traffic sign that says you can't go more than 25 kilometers an hour. Yes, you know what? You could put a sign that says no skateboarding. But what they've done here is a very elegant solution. They've actually installed these metal studs that are about 3 feet apart. And in all the time I've ever been to not only this location, but in any place where they've installed these little metal pegs, I've never seen any skateboarding. So to me, that's a great example of designing out a problem that, you don't need oversight, a sign. You don't need a compliance monitoring. There's no security surveilling the area to make sure that there's no skateboarding. So in real time for plants, designing out a problem is really an elegant way of eliminating the issue. Whereas if you take the compliance part, then you've got to write an SOP, You've got to have training in place. You also have compliance monitoring, and probably some indicator site verification that you're going to do. So, I think you can just pick your poison. Not every situation is going to be that you can design out. But what I would encourage you to always think about is, if you have a situation where you've designed out the risk, do not ever slip back and allow that risk to be then the design element taken out, and then now you're managing by procedures, because you're basically going in the wrong direction. Make sure that you're always holding on to those elements that are designing out the risk, and where possible, if you can design a risk, that is the best way to handle these situations. So I'll pass it over to the next poll question.
Thank you, Steve. And so we have a couple more questions in the poll as we're nearing the end of the presentation, and we'll move on to the Q&A. So this question: which best describes a hazard designed out in your plan? A, is it replacing hollow conveyors rollers with solid ones? B, installing sloped floors to eliminate standing water? C, seamless crack-free flooring to remove harborage sites? Or D, all of the above? Let's see what we have. There's some good engagement again on this question.
Well, it looks like people understand the concept of designing out.
Right?
The most recent example for me was I was in an airport taking a plane, and nobody ever has a situation where you're using the lavatory in a plane, and all of a sudden the door opens, because they've designed that risk out by the fact that to turn the light on, you have to actually close the door.
Right.
And so it's the designing out is a very elegant solution, and that should be kind of the level that you should be thinking when you're trying to design out food safety risks.
Great, thank you.
Okay.
And then second question fourth question for today. How does your plant think about drains in a swabbing context? Is it A, contamination source, high-risk primary Listeria spreader? B, a collection point, it gathers water and contaminants, not a primary source? Or C, both, depends on the situation? Or D, we don't have a defined approach for drains in our program? Let's launch the poll. Okay, we can start closing the poll now. All right, looks like the majority, Steve, is both. Depends on the situation.
Okay. That's interesting. So I think I would say that I would agree. So can we move on to the next page? I think I lost the ability to change. Oh, there we go. Okay. So the one thing I would tell you is that I think you need to really challenge your thinking around thinking that the drains are a collection point. And the reason for that is to think about the fact that, or at least ask the questions, is the floor wet surrounding the drain? If the answer to that is yes, then more than likely you have to start thinking about where that water is coming from, and really understand kind of where the sources are, because chances are, the first sort of thinking you should have is what is actually coming to the drain, and I think that's kind of what you need to really think about, and from a point of view that usually drains are not the problem. And if they are, then I hope that you have a drain backup policy in terms of what happens when there's a drain backup. Do the drains back up at all? Do they have backflow preventers? Are you actually, do you understand how the drains operate in your facility? If you have, an area where you've got ready to eat and you've got an area raw, do the raw drains flow into the ready to eat drains, or are they on separate systems? All those things become a consideration. If you ultimately really want to figure out, is it in the drain or is it something coming to the drain? Over the years, what I've done to help plants address that question is actually temporarily capping the drain off, and then swabbing around the drain to see if you can still pick up Listeria. And in all cases that we've ever done that, we've always determined that it was something coming to the drain. It wasn't actually the drain itself. That example, which I risked talking too much about the when I talk about whack-a-mole and having just keep treating the drain. The end story of that was I convinced them this thinking that it's something coming to the drain. I said, well, where, if there's water coming to the drain, where is it coming from? And what they determined was they had a conveyor that a small jump conveyor that they moved in and out depending on product type, and so they started swabbing that conveying system, and actually, good for them, they actually swabbed inside the electrical cabinet, and actually that's where they found Listeria. So it is, sometimes you have to kind of just open your mind to it, but I think it's this sort of challenge of you could look at drains almost the same way you think about remediation versus investigation. I think it's too easy at times to think that if you have a drain positive that it's the drain. I think the first course of action should be is to investigate, to really make sure that you've exhausted all possibility that it's not something that's coming to the drain. And if you've done that, and ultimately if your drain systems either are shared, raw ready to eat, or that there's a design issue there that either doesn't prevent backflow, or that the drains merge together in some way, then you know what, I have no argument that there's a risk there from a drain point of view. But I would say that drains are a good example of whether or not you are truly in investigative mode, or you're in that mode where you find a positive and you're only focused on remediation. Okay, so all right, so to wrap up then, we did talk a little bit about environmental monitoring. Again, it is not a control measure. So, environmental monitoring is really assessing how well our systems are working, the interventions, the ones that we're either managing by procedure or that we actually designed out the issue. When you get a finding, it should trigger seek and destroy, which means that you're looking to understand where the problem, how did the positive get to the surface that I swabbed, and where did it come from? So where it came from, how it got there, is all part of the seek process. The destroy obviously is destroying the source, and really remediating that source, and making sure that you've got all your stakeholders participating, and that you're really biased towards investigation versus remediation. The remediation part happens, that's the destroy part of seek and destroy. But you can't, and you should never put remediation ahead of investigation. And I think we talk about the final wrap up point. I think I just covered that. So with that, I think we'll move on. And I think there are some other thoughts, and we can open up for questions.
Yes, thank you very much, Steve. I loved how you shared hands-on examples, and shared your experiences as well on the topic. So we got a couple of questions today from the audience. Let's start with the first one. Could heat treatment be an effective factor for salmonella as well?
Yeah, what's interesting is you're going to want to make sure that you understand kind of what is the what temperature will kill the bacteria, the target bacteria. So I'll give you an example of that. So in the meat industry, lactic acid bacteria is a problem, not from a pathogen standpoint, but for shelf life. So when we pack products in packages, we if we have lactics growing, we have packages that either have purge that looks really gross, or you'll have distending of packages that also look very bad. And the one thing that we've learned about lactics is they aren't killed by regular temperatures that we use to kill Listeria. So I think it's about understanding the target organism that you're trying to treat. But heat is it's kind of like blunt force trauma, right? It's not an elegant way. I mean, I get a lot of questions from equipment suppliers and saying, why would you do that? Well, you know what? If you want to make sure that you have no harborage in equipment, there is no better way to make sure it doesn't have Listeria than heating equipment up. And what you're doing is you're killing bacteria through conduction. So in a mated surface, if Listeria is growing in a mated surface, gas is not going to get there, chemistry is not going to get there. But if I can heat the bacteria by heating the metal or potentially plastic parts and killing the bacteria because I'm heating it, that is an elegant way of killing the bacteria.
Thank you. Great answer. Okay, now we've got another question, and this time from Richard Wilson. Is testing an Enterobacter a good test? Sorry, is testing for Enterobacter a good test in a seeking investigation?
Well, again, if you're looking at testing generically, quite frankly, we do have other tools like total aerobic plate count, and there are many different things that you can do, but we're in the pathogen game, so testing for at the genus level gives us a lot of confidence that even if we're not dealing with the pathogen, we know that at the genus level, we will react whether it's pathogenic or not pathogenic. I think indicator organisms are good, but again, I would have to look at the various circumstances. But we can often look at aerobic plate count. There are other non-specific tests that can be done, but then you have to understand the relationships between them. But obviously, nothing's going to replace testing for the generic pathogen.
Okay, well, we're at time now, Steve. So thank you to the audience for participating, for your questions, and for your answers to the poll. We're going to wrap up now. And thank you so much for joining us today, Steve.
Thank you very much.
So appreciative of your time. Now let's get back to the presentation. We're going to announce next month's FSMA Friday. This time it will be with Tony Lucas, the presenter from the Acheson group, and we're going to talk about label verification, building a bulletproof process from artwork to shelf. You are welcome to register now. The registration page is on the Safety Chains website, and the event is on Friday, June 26th. Now we're going to talk about more resources. So there are plenty of resources out there. You can find some on the Acheson's website, or you can find some also on the Safety Chains website under a resources section. And all of the former FSMA Fridays are also there, so you can watch them on replay. Now we're going to move over to Ian, who's going to share a safety chain demonstration to help to leverage your EMP management.
Steve just walked us through what a seek and destroy response looks like when it's done right. The investigation mindset, the cross-functional team, the swabbing strategy. The harder question is, how do you actually make that process consistent at your plant when you're the one managing it and you've got multiple lines, hundreds of people, and even when you have to deal with it maybe at 2 a.m. With multiple people on the phone? Well, that's what I want to show you briefly in Safety Chain. We can help you strengthen your food safety program through digital EMP management. What that looks like is taking the data from your EMP program and making it digital. Our platform is built for food and bev manufacturers just like you. So you'll get results trending on dashboards. You'll be able to track your corrective actions directly linked to your failures, kick off really tight controlled processes for performing the seek and destroy process, as well as following up on any preventative measures put in place. This will ultimately lead to fewer repeat positives, stronger audit confidence at your facility, and a plant team that can execute without the expert being on the phone or being at the plant to guide everyone. That's what your plant can look like in the future with Safety Chain. So we'll take a look into the platform. I'll show you a few key elements, and then the webinar will be over for the day. On our Safety Chain records grid, we get access to your environmental monitoring program data instantly, and you've got a lot of great ways to be able to filter it and track and trend your results. So I'm filtered on my one form across 7 locations that I manage. I can see the lines that we are doing our swabbing on. So line 1, section 3, S4 pieces of equipment, as well as exactly where we did the swab. So this is extremely helpful to have this data digital. So on the stick machine wheel or the floor below the wrapper, we have the specific information, the line and the equipment, as well as the date, who did the swab, and even pictures of the swab results. If your swabs are being sent to a lab, you can kick off a subsequent form for lab results linked directly to the original swab, and you'll be pending the results on both forms, specifically the lab result form. And that's an easy workflow we work with quite often. Adding pictures to your swabs is extremely important information to have and very relevant to help plant teams in their processes. So attaching a photo of the swab location is very common for the customers that use Safety Chain and is done in other systems, but having everything under one roof is really beneficial to get all teams on board and help develop a stronger food safety culture. It is really pertinent to be able to link your corrective actions to potential positive results of some of your swabs. And that is done in a really nice fashion in Safety Chain. So we can automatically kick off workflows for any result of a form based off of the criteria that you determine, or you can do one-off CAPA creations for anything that fits your needs. In addition to this, we have plenty of reporting capabilities. So I've configured one environmental monitoring dashboard that I'll walk through here in just a moment. It's linked on my home page and it's right under my dashboard section. So with one click, I'll be able to drill into my dashboard to track and trend my results. Now this can be available to any user or specific defined users for your plant. Now here I have tons of data that's going to help me hone in my focus and my process at my facility or multiple facilities. So what equipment have we been using? Where are the locations? Have we had any positive results? So quick, we have one. An alarm monitor, so I can drill into records off this dashboard as well. So very easy to work with the platform. All of the data is really linked nicely, and you're going to have a lot of capabilities to manage your program. So whether you're currently doing it on paper or SharePoint or Excel, it can be cumbersome and it can be very reactive and slow to making positive change. With Safety Chain, it's just another tool in your kit of pretty endless possibilities with the platform, and one that we recommend to a lot of our customers. And that'll wrap up our FSMA Friday presentation and webinar for the month of May. Thank you so much for joining. And thank you, Steve, for all the incredible information. If what you saw on Safety Chain is of interest, or if you think your plant should be adopting a digital EMP program, please get in touch with your customer success manager or anyone on our staff. We'll be happy to see if it's a good fit for you and help you design it with one of our industry experts. Thank you so much for your time today. Everyone, take care.
All right. Well, thank you, everyone, for joining and participating today. And thank you again to Steve Tsuyuki and to Ian Hildebrand. Looking forward to having you all back in June, and bye.